Solving linear equations by clearing fractions. When you have an equation to solve that has fractions, there's some steps we can follow to make the algebra easier. If we could remove the fractions, the equation would look a lot nicer and be a lot easier to solve. So that's what we're going to try to do. So the first step is we're going to look at the bottom of the fraction, that's called the denominators, and we're going to try to find a least common denominator. So how do we do that? Let's look at the three different denominators we have. We have a 5, we have a 2, and we have a 15. Let's look at those numbers. So what we want to do is list out the multiples of each of those numbers. So for 5 to start with, the multiples of 5 times 1 is 5, 5 times 2 is 10, 5 times 3 is 15. The multiples are 5, 10, 15, 20, 25, 30, and so on. We'll list the same for 2, the multiples of 2, 2, 4, 6, 8, 10, 12, and so on. And we do the same for 15. 15 times 1 is 15, times 2 is 30, times 3 is 45. I don't need to write as many terms out because they're getting so big so fast. But for the least common denominator, the challenge is to figure out which number is the smallest number that you can see in each of those three lists. So I look at each of these three lists and I see that they each have a multiple of 30. That's the smallest number that I can find in each of the lists. So the least common denominator is 30. So step 2 says, now that we know the least common denominator, multiply both sides of the equation by 30. In this case, I'm going to actually multiply every term I see on both the left and the right by 30. If you do the same thing to every term, it's not changing the equation at all. So that's step 2. I multiply everything by 30. And the reason I'm doing that is because if you take that 30 and then you divide each of the denominators will cancel and we won't have fractions anymore. So for the first term, 30 times m minus 2 divided by 5. 30 divided by 5 just becomes 6. So we'll have 6 times m minus 2. For the next term, we'll have minus 30 divided by 2. That's minus 15. Times m minus 4. And then on the other side of the equation, 30 divided by 15 is 2 times m plus 5. And then the last term, there's nothing on the bottom. There's no denominator, so it's just 30 times 2 is 60. So now we can just distribute, combine like terms, and solve. So we get 6m minus 12 minus 15m plus 60 equals 2m plus 10 plus 60. And now we'll combine like terms. 6m minus 15m is minus 9m minus 12 plus 60 is plus 48. And then on the other side of the equation, we will have 2m plus 10 plus 60 becomes plus 70. Now I'll collect all the m's on the left side of the equation by subtracting that. And then I'll collect all of the numbers on the right side of the equation by subtracting 48 from both sides. Now I'm running out of room here, so I'll move over here. We end up on the left getting minus 11m, and on the right we get 70 minus 48 is 22. So our last step is to divide both sides by minus 11, and that leaves us on the left, we'll just have m equals to minus 2. Okay, it was a lot of work, but we did it. Let's do another example to practice. So I see this ugly equation with a lot of fractions, And I know I want to try to remove the fractions to make it look a little bit nicer. So my first step is to find the least common denominator. I need to look at the 2, the 4, and the 3 and figure out what is the lowest number that's a multiple of all of them. So I'll list all the multiples of 2. 2, 4, 6, 8, 10, 12, 14, 16. We could keep going, but now I'll list all the multiples of 4. Okay, they get bigger a little bit faster. 4, 8, 12, 16, and 20. And now I'll list the multiples of 3. 3, 6, 9, 12, 15, 18, and so on. Now I ask myself, what is the smallest number that's in all those lists? It's called the least common denominator. So the smallest number that I see in all the lists is 12. So that's the number I'm going to use. Okay, so for step 2, I'm going to take that number 12 and multiply it on both sides of the equation. Even more specifically, I'm going to multiply every single term of this equation by 12. If you do the same thing to every term, it doesn't change the equation. And the reason I do that is because I know that that number 12, when you divide by the different denominators, it will cancel the denominators totally. So look at the first term. 12 divided by 2 is 6, and we still have the y plus 5 left over. So I did this 12 divided by this 2, and I have y plus 5 left over. 12 divided by 4, in this case we've got minus 3, and I still have the numerator left over, y minus 2. Then on the other side of the equation, I've got 12 divided by 3 is 4, and I've still got the top part left over, that's y plus 7. And then lastly, the last term is 12 times 1. There's nothing divided, so we can just leave it as that. Now it's a much prettier algebra problem when we don't have any fractions. We're just going to distribute everything and then combine like terms and isolate the y and hopefully solve. So when we distribute, we get 6y plus 30 minus 3y plus 6 on the left. On the right, we get 4y plus 28 plus 12. And then we will combine like terms, y's with y's, numbers with numbers on both sides. 6y minus 3y is 3y, and 30 plus 6 is 36. And then on the right, we've got 4y, 28 plus 12 is 40. Now I get all the y's on the left, all the numbers on the right, and we should be able to simplify. So I will subtract 4y from both sides, getting all the y's on the left. I will subtract 36 to get all the numbers on the right and see what happens. The 36's cancel, the 4y's cancel, and I'm running out of room, but we can move over here and say 3y minus 4y is minus 1y on the left. 40 minus 36 is 4 on the right. Now we want to isolate y all by itself, so we will divide both sides by minus 1. And then what is left on the left is just y, what we wanted, equals minus 4. So we were able to solve this very messy equation by first removing the denominators of all the fractions and then using our basic algebra skills to solve.